Hey everyone, the title of my paper is Approaching the Limit of D3 Visualizations Applied to Big Data and Web Browser. That is a mouthful, so let's break it down a little bit. Visual analytics focuses on gathering insights from data. This could be of benefit for big data because it would facilitate the process of finding patterns, trends, etc. from a large volume of data. In this research, I investigate the boundaries of making data visualizations in the web browser. There are many tools for visualizations, one of which is D3, a JavaScript library commonly used for data visualizations in the web browser. In this research, the chosen visualization is a simple bar chart. This is because more complex visualizations would require more code and more memory capacity, so to test the boundaries, I want to make it as simple as possible. You might be wondering, what is this boundary about? Why is there a boundary? Well, web browsers typically have a per tab memory limit. The chosen web browser in this paper is Google Chrome. The memory limit for Google Chrome is not well documented, but many have tested it and found it to be up to around 4 gigabytes. But what does that mean? Can you load a CSV that is 4 gigabytes and still make a D3 visualization? Because making and displaying the visualization also requires memory, so this is the boundary that is tested in the paper. To test the memory, I generated some data files. I chose to use two common types of files, CSV, preferred by many, and JSON files, which stand for JavaScript Object Notation, thus optimal to use in JavaScript projects. These two files are very small, around 10 megabytes. These two are around 200, and these two are around 500. In this video, the 500 megabyte CSV file is being parsed. The video is sped up, so it's not the actual speed that this happens. You can imagine it takes longer to read the file. If you look at the resource monitor on the right of the page, you can see how the memory goes up, then it comes down a little bit. This is known as garbage collection. The browser gets rid of things it doesn't need anymore. While you are looking at this, I want to provide you with some background information. In this situation, the CSV file is an external file, so it has to be parsed by the browser first, and then the data can be used for a visualization. But parsing takes time and memory. How much of each depends on the type of parser. Some parsers are meant for efficient and fast parsing of certain types of files. In this video, the D3 library parser is used. Back to the video. You can see how the browser pauses because it suspects a memory crash soon. In the resource monitor, you can see that the memory is around 4 gigabytes, thus approaching the limit. And now you can see the browser crashes. A similar situation happens for the JSON file. I will not show that video because the same thing happens. So what I have found is that parsing an external file that is less than 1 gigabyte crashes the browser. That is very little. So is this really the limit? I have tried a different approach, and that is generating data directly in the browser. That is what you see here. I'm generating 1 gigabyte in the browser. This goes much faster, and actually the browser does not crash. It successfully makes the D3 visualization, which in this case is a bar chart. Here you can see the bar chart. This was made with 2 gigabytes. The video is sped up, but as you can see, this huge bar chart does not offer any insights. It's very slow, and the x-axis is basically unreadable. But this is just a simple example, and other types of visualizations that are more suitable for big data can be used next time. What were the results? For external files such as CSV and JSON, the browser crashed for less than 1 gigabyte. This is because actually parsing, reading, and converting these files requires a lot of memory. Generating the data directly in the browser was much faster and more efficient, making the D3 visualization did not require much extra memory because next to data that is 4 gigabytes, it still manages to finish the visualization before the browser crashes. However, there are some limitations. I only tried 2 different parsers for the CSV file and 2 for the JSON files. Perhaps other parsers could have been more efficient. Furthermore, Bar charts are not typically used for big data. Usually, there are more complex visualizations which may require more memory. Finally, most data generation in the browser is not possible, especially for big data. It's not representable of real life. Conclusion: try to transform the data before making the visualization in the browser with D3.